From the past lessons, we learned about variance and standard deviation. Both are measures of dispersion in a dataset and is commonly used to express how far apart individual points of data is from the mean or average. When having two datasets with the same mean, it is easy to compare because we can just directly take their standard deviation and interpret the difference as is. However, comparing the variability of two datasets with different means can be challenging because the standard deviation alone does not account for the scale of the data. Standard deviation measures the average amount by which individual data points differ from the mean of the dataset. It provides an absolute measure of variability. However, when the means of two datasets are significantly different, comparing their standard deviations directly can be misleading. A higher mean can naturally lead to a higher standard deviation, even if the relative variability is the same. Consider two datasets. Dataset A with a mean of 10 and standard deviation of 2. Dataset B with mean of 100 and standard deviation of 20. At first glance, it seems dataset B has a much higher variability. However, this might simply be because dataset B has a higher mean. To understand the relative variability, we need a normalized measure. The coefficient of variation is a standardized measure of dispersion of probability distribution or frequency distribution. It is expressed as a percentage and it's calculated as the coefficient of variation is equal to the standard deviation over the mean times 100%. Coefficient of variation provides a measure of relative variability, allowing us to compare datasets with different means on a common scale. Since coefficient of variance is a ratio, it is independent of the units of measurement, making it a dimensionless number. This is particularly useful when comparing variability across datasets that are on different scales. Let's compute for the coefficient of variation for the example datasets. Dataset A, coefficient of variation is equals to 2 over 10 times 100%, which is equals to 20. Dataset B, coefficient of variation is equals to 20 divided by 100 times 100% is equals to 20. Despite the different means and standard deviations, the coefficient of variation shows that both datasets have the same relative variability of 20. Using the standard deviation alone to compare variability can be misleading when the means are different. The coefficient of variation normalizes the measure of dispersion relative to the mean, providing a more meaningful comparison of variability across datasets with different scales or units. This is why the coefficient of variation is preferred for such comparisons.